Welcome everyone. So we will be discussing Indian contribution to science. This is a book which is compiled by Vigyan Bharati, and this is one of the chapters which is there for the VVM examination.
Chapter 16 India in Space, a Remarkable Odyssey. The dream and realization of spaceflight. For thousands of years, humans have curiously gazed at the night sky and dreamt of traveling to space and explore the distant heavenly bodies there. But that long cherished dream became a reality only after they developed a large rocket capable of carrying satellite and human to space. After reaching space, these rockets were powerful enough to make satellites, robotic spacecrafts, or spacecrafts carrying humans to either circle the Earth or proceed towards the other worlds of our solar system. Besides satisfying the human's urge to explore space, devices launched into space by humans have made our lives here on Earth easier and safer. Thus, benefits offered by space are truly revolutionary. Now, let us understand the term space. When we talk of space research or space flight today, the word space refers to the region which is outside the Earth's atmosphere. Today, many scientists agreed that space begins at the altitude of about 100 kilometers from the Earth's surface. Thus, all heavenly bodies, including the sun, moon, planets, stars, and galaxies, are in space. Artificial satellites revolve round the Earth in space. Humans living in huge international space stations today are circling the Earth in space. The uniqueness of the Indian space program. India is one of the few countries that have been taken up the challenge of exploring space and utilizing space for the benefits of the common man. For this, the country has developed various technologies which few other countries have done. India's achievements in space today are the result of the far sightedness of Dr. Vikram Sarabhai, one of the greatest sons of India. Sarabhai was a great dreamer and showed the path to realize those dreams. He had firm belief in the power of space technology to bring about rapid and overall development of India. Professor Satish Dhawan, who succeeded Dr. Sarabhai as the head of Indian space program, made immense contributions to the Indian space program by assigning great importance to developing and mastering space technologies through indigenous efforts. He also laid emphasis on the involvement of Indian industry to meet the needs of the space program. Professor U.R. Rao, Dr. K. Rangam, Dr. G. Madhavan Nair, Dr. K. Radhakrishnan, who succeeded Professor Dhawan, have made their own unique contribution to Indian space program. The beginning, through though India today is considered as one of the prominent countries conducting many space activities, the Indian space program began in the modest way with the formation of Indian National Committee of Space Research by the Government of India in 1962. The program formally began on 21st November 1963 with the launch of a 28 feet long American Nike Apache sounding rocket through Tumba near Thiruvananthapuram. It carried a small French payload scientific instrument, that is, to study the vents in the upper atmosphere. Surrounding rockets are small research rockets that carry instruments to study upper atmosphere and space. They cannot launch satellites. Nearly 50 years later, on 9 September 2012, India celebrated its 100th space mission. The historic mission was performed by India's Polar Satellite Launch Vehicle PSLV 21, which launched a French and a German satellite together, weighing 750 kg very accurately into the required orbit. This shows as to how far India has traveled in space and has attained mastery over space technology. During the 1960s, India conducted space research mostly through surrounding rockets, but the country also established a ground station to conduct various useful experiments using communication satellites. India space capabilities. Indian Space Research Organization, which is widely known as ISRO, is the agency which implements the country's space program on behalf of India's Department of Space. ISRO came into existence in 1969, the same year when humans set foot on the moon for the first time. Various centers of ISRO are now spread all over India. They include Vikram Sarabhai Space Center VSSC situated in Thiruvananthapuram, which designs huge rocket capable of launching large satellites. In the same city is Liquid Propulsion System Center LPSC that develops liquid rocket engines and the more efficient and highly complex cryogenic rocket engines. Bangalore can be called as the space city of India. It has got many space related facilities including the ISRO Satellite Center which builds Indian satellite. The famous Chandrayaan 1 spacecraft that conclusively discovered water on the moon was built here. Moreover, the ISRO headquarters and the Department of Space, which steer the Indian space program, are in Bangalore. ISRO Space Application Center at Ahmedabad develops payload for the satellites. National Remote Sensing Center NRSC is another import center of ISRO. It is situated in Hyderabad and performs the important task of receiving the pictures sent by India's remote sensing satellite in the form of radio waves. The island of Sriharikota in Bay of Bengal has ISRO's Satish Dhawan Space Center and it is the space port of India. Sriharikota lies about 80 kilometers to the north of Chennai and lies in the Nellore district of Andhra Pradesh. This is a place from where 38 Indian built rockets have lifted off on April 2013 and have traveled towards space. It also has facilities to assemble huge satellite launch vehicles as well as launch and track them. Into the satellite era, in the 1970s, India took a giant leap into the space with the launch of first satellite Aryabhatta named after the famous ancient Indian astronomer. The satellite weighed 360 kg at the time of its launch. Aryabhatta looked like a large box with many faces, that is polyhedron. The satellite's entire body was covered with solar cell that generated electricity when they were exposed to sunlight. Aryabhatta was built as to understand the challenges involved in building a sophisticated device like a satellite. Nevertheless, it was a scientific satellite as it carried three scientific instruments to study sun, distant heavenly bodies, and the Earth's ionosphere. On 19th April 1975, a Soviet rocket carried Aryabhatta into 600-kilometer high orbit. Aryabhatta laid a firm foundation to the India satellite program. With this, Indian scientists moved ahead and began building Bhaskara 1 satellite, which was intended to conduct Earth's observation. Bhaskara 1 was also launched by the Soviet rocket into orbit in June 1979. It carried a TV camera for taking pictures of Earth's surface. Besides, it carried a microwave radiometer, an instrument to study the Earth. A similar satellite, Bhaskara 2, was launched in 1981 on another Soviet rocket. The experience gained during Bhaskara program was the foundation stone for the later ISRO, that is Indian Remote Sensing IRS satellite program. Next, coming to geosynchronous orbit, which lies at the height of about 36,000 kilometers from the surface of the Earth, which of course is almost one tenth of the way of the Moon. A satellite circling the Earth at a height takes 24 hours to go round the Earth once, since the Earth takes 24 hours to spin around its own axis. Once the satellite speed is synchronized with the Earth's spin, hence the name is geosynchronous orbit. A satellite in such an orbit placed over the equator is called a geostationary satellite. In the late 1970s and early 80s, ISRO scientists also built the Rohini series of the satellites and gained a traditional experience in building satellites. Rohini satellites were launched by India's first indigenous launch vehicle SLV-3. Satellites as a catalyst of development. In the early 1980s, the power of artificial Earth satellite to bring up phenomenal growth in India's television, broadcasting, and telecommunication sectors was glaringly demonstrated by a satellite called Indian National Satellite 1B INSAT 1B. It was the second satellite in the INSAT 1 series because of the failure of the predecessors INSAT 1A. Indian space scientists were very much concerned, but INSAT 1B brought in a major revolution in Indian telecommunications, television broadcasting, and weather forecasting sectors in a very short and unthinkable time. INSAT 1B facilitated the rapid expansion of essential telecommunication facilities like telephone, telegraph, and fax across the country. Through INSAT 1B, mountainous, inaccessible, and isolated regions of the North and Northeast India, as well as island territories of Andaman and Lakshadweep, could be easily accessed. Enhanced services of INSATs. The indigenously built INSAT 2A has 1.5 times the service capability of the earlier INSAT 1 satellite and weighed almost twice as launch. Like INSAT 1 satellites, it too carried transponders for telecommunications, TV broadcasting, and an instrument for weather observations. Beside it carried another special instrument capable of sensing distress signals sent by special transmitters in vehicles and even held by individuals in danger. As time progressed, three more satellites were launched in the INSAT 2 series. They are called mobile service transponders to facilitate communications between the vehicles and stationary users. Special mention has to be made about GSAT 3 or EduSat, which was a satellite dedicated to the fields of education. It facilitated the provision of equality education service to rural students through ISRO's tele-education program. Today, there are about 56,000 classrooms in the EduSat network. Another such service provided by INSAT or GSAT satellite today is telemedicine service. ISRO's telemedicine program links doctors at super specialty hospitals in the urban areas to the patients at the rural hospitals through audio video facilities via satellite. One more interesting aspect of GSAT series of satellites is that GSAT 8 and 10, launched in 2011 and 12, respectively, carry a Gagan transponder that broadcasts navigation signals. Gagan program boosts the quality, reliability, and availability of navigation signals broadcast by American GPS series of navigation satellites. In addition to the communication satellites, India has built another type of satellite called the remote sensing satellite. In fact, India has emerged as one of the world leaders in the field of remote sensing satellite. Eyes in the sky. So, what are these remote sensing satellites? How do they what did it do? How are they useful to the society? To understand this, let us begin with the word remote sensing. When we say remote sensing, it means that it is a method of collecting information about an object or a phenomena without having any physical contact with it. Satellites carrying very sensitive cameras or radars and circling the Earth in space hundreds of kilometers high are known as remote sensing satellites. These transmit the pictures to ground stations through the radio. Such pictures, taken in different colors or in black and white, show a lot of details. Trained scientists can manipulate and analyze those pictures in computers to understand several facts like estimating the net zone area, then underground water availability, mineral deposits through rocks, color, environmental assessment, pollution levels, wasteland development, and so on. Quenching the thirst for knowledge. Communication satellites, weather satellites, and remote sensing satellites are satellites that make our life easy, interesting, and safe. In addition to this, ISRO scientists have built scientific satellites that quench the human thirst for knowledge, especially to understand our universe. But the satellite ought to be more precise. The spacecraft which reveal the prowess of Indian scientists to efficiently explore space was Chandrayaan 1. Since Chandrayaan 1 went towards some of the other heavenly body instead of permanently circling the earth, it is appropriate to call it a spacecraft rather than a satellite. Chandrayaan 1 demonstrated many things, including India's ability to do meaningful science at a low cost, its ability to assume leadership in a cooperative space venture, and develop the essential technology within the stipulated time. Chandrayaan 1 made the outside world to look at India and enhance respect and galvanize students' community within India. It became prominent milestone not only in the history of Indian space program but in the history of India's itself. One of the main objectives of Chandrayaan 1 was to further expand the knowledge about the moon, make more progress in space technologies, especially by decreasing the various internal organs of satellite or a spacecraft, and provide challenging opportunities to India's large younger generations of scientists to conduct research about the moon. Having proved India's ability to successfully explore another heavenly body, Chandrayaan 1 collected massive amount of scientific data including pictures. Chandrayaan 1 has detected water molecules on the moon. This was the path-breaking discovery indeed. Before Chandrayaan 1 went to moon, scientists were not certain about the presence of water on the moon. Thus, it was India's Chandrayaan 1 which made a major discovery about the moon. Along with this, scientists were able to sense the height and the depth of various features on the lunar surface. Chandrayaan 1 thus became a symbol of India's success in space. Building back from space. Another remarkable achievement of ISRO is related to bringing back an object from space safely. The experiment, which was performed in regard, was called Space Capsule Recovery Experiment 1 SRE1. The 500 kg SRE1 capsule carrying two experiments was launched in 10th January 2007 in PSLV, and following 12 days it circulated the earth at about 600 kilometer height. Thus the very first attempt of India to bring back a device which it had launched into the space earlier was a great success. Next, we have launch of 20 satellites through a single rocket, an example of frugal engineering. ISRO crossed a milestone on 22nd June 2016 by launching 20 satellites through a single rocket. It crossed its own record on launching 10 satellites in a single mission. ISRO is second to Russian rocket launching a record of 37 satellites in a single mission in 2004. In the major milestone mission, besides the primary Cartosat 2 series satellites, the PSLV 34 rocket launched two satellites from Indian University, Satyabama University, Chennai, and College of Engineering, Pune, and 17 foreign satellites, including one for a Google company, the 725.5 kg Cartosat 2 series of satellite will be for Earth observations, and its imaginary would be useful for cartographic applications, urban and rural applications, coastal land use and regulations, and the utility management like road networking. There are 35 Indian satellites in the orbit, and about 70 satellites are needed in the next 5 years, besides the contracts signed with the foreign companies. Hence, ISRO will go for more multiple launch missions than single mission. Indian space program is one of the important resource of the foreign revenue. ISRO's commercial branch generated a revenue of about rupees 1800 crore during the last fiscal year, and a major share of the revenue was obtained by leasing out transponders during 2016-17. More multiple satellite launching will be taking place from Sriharikota. Indian space program is attractive to foreign firms since the mission has low budget in comparison with those of the other countries. Engineering program with the minimum budget providing maximum gain in the energy engineering. Indian space program is best example of frugal engineering. The success of Chandrayaan mission initiated the quest for Mars through the Mars orbiter mission or Mangalyaan. India became the only country to orbit Mars in the first attempt. The success of Mangalyaan put India on the elite club of nations to have achieved interplanetary missions. The successful testing of air-breather propulsion system and the scramjet rocket engine has put India among the space technology giants of the globe. With Antrix Corporation baking deals of foreign satellite launches, it is certain that in future ISRO is to set to rise as the most sought after governmental space agency.